Test, test, one, two, three, four. We are live, baby. How's it going? My name is Pete. Tyler and I are the hosts of Two Men, One Course podcast. Second episode. Woohoo! We made it here. um, anyway, so my name is Pete. So Tyler and I are the hosts of this podcast, and we're just two guys hanging out, talk about chemistry. And if you love to hear about chemistry, well, very welcome to join us. We're gonna start right here. Well, I've got a quick question for you. Do you know how does an ocean say hi? Yep. How does an ocean say hi? Well, it waves. Pass, pass, pass. That's just that joke. Well, welcome to experiment number one. What we're gonna do? Well, measurement and density. These are like the basic measurement in chemistry. Okay, and let's see if you enjoyed it. All right. Before we get to the detail, what you be doing in the lab, let's talk about the theory behind it real quick. Okay. I'm sure you learned this in the lecture already, but we just want to make sure we'll be on the same page here. All right. First of all, look at this leaf right here. How long is this leaf though in centimeter? Yes, so we have unit right here, centimeter. Help you a little. So that's the length. Is in between 3.5 and 3.6. Okay. When you read the length of this leaf, well, what for sure, right? You certain for sure that this leaf is longer than 3.5, but not as long as 3.6. So when you go read this length, you're gonna go with 3.56, 3.57, 3.58, right, and 3.59, but maybe not 3.59. That's a bit too high. Okay, but my point is the first two digits here, 3.5, that's we for sure, right? So this leaf is longer than 3.5 because certain numbers. And the last digit right here, we guess, right? We guesstimate it's gonna be somewhere closer to 3.6, but how? Because 6, 7, 8, or 9, all right? So the whole this number, so you have three digits here. All this we call significant figures. Okay. By definition, the significant figures contain certain digits. So the first two and plus one estimated number or uncertain digit. That's the last one that you guess. Okay, the last digit right here tell you how accurate an instrument is, and it will become very important. Without last number right here, you're gonna get only 3.5, which is still have some uncertainty. Okay, the last digit right here add your number closer to the real value. Right. So anyway, my point is significant figures contain all the whole certain digits, how long it is, that doesn't care. These are certain digits plus one estimated number at the end. All right, and the significant figures must carry value of the subject being measured. Take a look right here. All right, how many significant figures are there? Well, we have 1, 2, 3, 4, 5, 6. So we can say, oh, there are six sig figs. So six sig figs. Okay, try this object. How many sig figs are there? Well, in this case, we're gonna go only 3 sig figs. The first two, we don't count them as a sig figs because one, they don't carry the weight of the object. Okay, and two, these two numbers just serve as a set decimal point. The last one right here, this one actually carry the value of the subject of the object being measured because it's 2.80. Not 281, not 282, it's 280. Okay, try one more time. So how many sig figs are there? When you count, we're gonna count 1, 2, 3, and 4. Don't count the first one, so 4 sig figs only. The first 0 serve as a set decimal point. Okay, and the last two 0 on the right side, those that carry the weight is 3021, not 31, not 25, something like that. All right. Okay. All right. So significant figures. All the certain digits plus estimated digit, and sig figs must carry the value of the object being measured. Let's try this one. Okay, so what's the length of this leaf? Well, for sure, certain that it's longer than 3. All right, so when you read this number, it's going to be 3 and something. We're going to go 3.5, 3.6, 3.7. These are acceptable number. All right, so there are 2 sig figs. The first one is certain digit, and the second one, the last one, we estimated either 0.5, 0.6, 0.7 is close enough. So the total number of sig figs is 2 sig figs. Okay, yep, that's pretty much it. All right, now let's try and do something the volume. right? When you read the volume, some you have to learn this in high school, but if you have not, well, let's talk about it real quick. The level of a liquid doesn't have to be water, right? Most liquid, you're gonna see a curve like this on the at the top of the surface. Okay, we call meniscus, and this gonna make a little bit kind of challenging to read the number, the volume, right? So what do we do? Every time when you read volume in a graduated cylinder, you're gonna put your eyes level right at the meniscus, right at the meniscus, not from the like the top view to the bottom view. Are gonna be like at the right meniscus. Okay, and read. Let's try this one. All right, how do you read the volume of water? Well, you can pause the video and let's go with me. Okay, let's say what we got here. We got this is 6, this is 7, so each one's 0.1, 0.2, 6.3, 6.4. Okay, so it's above 6.3, below 6.4. We're gonna go 6.31, 6.32, 6.33. 6.3 is our certain number. We sure it's 6.3, but something else. So you have estimated the last number. So we're gonna go 6.31, 2, 3, or 6.34, something like that. Okay, so this graduated cylinder gives you 3 sig figs. All right, next one. Let's say what we do here. How many sig figs can you read? All right, how many sig figs can you read? Let's see what we got here. So we got 20, 21, 22, 23. So this is 22. 21, 22. So it's above 22, but less than 23. So I'm gonna go with 22.4, 0.5, 0.6, so 3 sig figs, something like this. Try one more time. Try one more time. So how many sig figs you can read? Well, let's say this is 19, this is 20, this is 21. All right, that's a 20. So when you go 20.2, 0.4, 0.6, so it's above 20.6. So that's 3 sig figs already, all right? So we sure this is 20.6 for sure. It's above 20.6. So you have to guesstimate another number at the end. So I'm gonna go 20.61, 22.62, 22.63, 20. No, I said wrong. 20.61, 20.62, 20.63, not 22. Okay. All right. So basically, what you read, all the number that you turn 20.6, and then you add estimated number at the end. So this graduated cylinder give you 4 sig figs. Okay. So this is 20, not 22. All right. Now that's how you read the number, the weight, okay, the length. Now we're gonna go to the accuracy, how accurate your measurement is. But before we get to the details, so what is accuracy exactly? All right. So easy, like very easy example right here. So you play dart, where you're gonna throw the dart to the target. All right. This is accurate, and we all know this is accurate. This is not accurate. Okay. And this is worse. So now what is accuracy exactly? Well, accuracy reflects how close the measured value is to the true value. So we compare all this dot to the in the middle. That's a true value. Okay, so we compare to the in the middle. In your measurement, there will be one single value that's a true value, and how close your measurement is to that value, that's tell you about accuracy. All right, give you some example. Right? Let's say there's an object. The true weight of this object is 2.111 gram. Really accurate. Yes, 4 sig figs. Yeah, 2.111 gram. Now, you have 3 balances. Okay, balances A, B, and C. Right? And you're gonna weight. You take this object, weigh on balance A 4 times, B 4 times, 3 4 times, and you get these numbers. Let's take a look. Now, I'll have you guess which one is the most accurate. Well, if you analyze it, look at this number more closely, right? So that's how much is A, give the numbers is off from the true value. Not that accurate, okay? For B, a little more accurate, right? Closer to the true value, 2.111 gram, right? In C, really, really accurate, more accurate than the rest, all right? Now, looking like this, it's more like just look at the number and tell how much which one is more accurate. I mean, it's just kind of like guessing. Can we make it a little bit more quantitative? Okay, we call percent error. All right, so we're gonna take usually when you have multiple numbers, like when you do an experiment a few times, you average out, in this case, the weight, and then you're gonna plug in the this equation, right? So we have experimental value with the average out these four numbers, plug in here, and then minus theoretical value, which is the true value, 2.111 gram, and then divided by 2.111 gram, that's also theoretical value, times 100. That's a percent error. It tells you how off your measurement is. Okay. All right. Halfway, we can make this podcast without our sponsor. Let's talk about sponsor of this podcast. Hello Fresh. You guys like cooking? Well, cooking could be a little bit difficult. It comes with some other consequences. You have to go to the grocery store, you have to cook, you have to cut, you have to clean, which is a lot of things that you have to do. Okay, HelloFresh makes stressful meal planning and going to grocery store an enjoyable experience. If you don't know that, that's HelloFresh. You can get dinner to the table in 30 minutes or less. And the recipe are delicious, carb smart, low calories. They even have the vegan, vegetarian option. Okay, you can cook by yourself, with friends, or in a party. And guess what? If you listen to our podcast, you will get 12 free meals and free shipping. Go to hellofresh.com and enter code TUSKY 2022. So TUSKY is spelled T as in thorium, U as in uranium, Z as in zirconium, K as in K as in kinky, I don't know, I as in iodine, and 2022 to get 12 free meals and free shipping. All right. I'm joking. Do not go to hellofresh.com. This is not a real podcast. So some of you are like, hey, we have a promotion code. No. We have nothing to do with HelloFresh. No, it's not a joke. Okay. All right. What are you gonna do in the experiment this week? Now you're gonna go to lab. You will do three things. There are three parts in this lab. Okay. Now, in part one, you're measuring some stuff. Read the weight, volume, temperature. Part two, use some accuracy and percent error. We'll just talk about it, right? And part three, we have some density of unknown solid. You'll find the density of it. Okay. All right. Let's a little bit about detail. Part one, you will have two objects. We don't tell you what it is, what they are. Right? You will put each of these objects to two balances. One is triple beam balance. The other one is analytical balance. Okay, and wait for it. Let's see which one's more accurate. Okay, that's the weight. Now, volume, we have three containers. Your TA gonna put some water or liquid in here, and you're gonna go read it and record the volume of each container. Okay. One thing you don't forget though, when you read a volume, you will see a meniscus. Your eyes level, eyesight right at the meniscus, not from the top view, not from the bottom view, just right at the meniscus. Okay. And the temperature, so we have an analog thermometer and a digital thermometer. Right, you're gonna read the number on it. Right. So all this, the part one right here. So make sure you write all numbers with proper significant figures. Remember what significant figure is? All the certain digits plus one estimated number. Okay, except the digital one. Digital one just give you right that number already. All right. Now that's part one. That's it. It shouldn't take long. Maybe 15 minutes, 20 minutes. Part one, it should be less than that. Right. Now in part two, I'm going to talk about how accurate your measurement is and talk about percent error. Okay. You will obtain two numbers. In this case, we're going to use volume. Yeah, two numbers, two volumes. You obtain measured volume and then calculated volume. Right. The calculated volume, that's your theoretical volume, and the measured volume is just that's from experimental value, and then you do percent error off of them. Okay. Here's how it works. You're gonna take a one graduated cylinder. You're gonna add some water up to it. Look at the left hand now how much you have to add. Okay. Read number with a great significant figure, because without significant figures, your number is gonna be off quite a little. Right, so be careful. All right, once you read that, that's your measured volume. That's it, super simple. That's a measured volume right there. And then now, calculated volume. How you get calculated volume? Well, you're gonna do this. You're gonna take this graduated cylinder with the water in it, put on the scale, right? Put on the analytical balance. Read the number. You're gonna have the weight of the container plus water. Quick question: if I want to know the mass or the weight of just the water, what should I do? Right now you have a graduated cylinder with water in it. So you have a weight of container plus water that you read on here. Right? Is it this weight container and water. If I want just the weight of water, what do we have to do? Well, I have to subtract, which is the weight of the dry container. Okay, so before you add water at the beginning, just weight the graduated cylinder, the container first. That's the dry one, right? And you're gonna subtract right here. You get the weight of the water. Plug this in the density equation. Man, it's a mass right here. It's a mass of water. The density of water is about 1, but it varies uh, varies by temperature. So in the lab handout, I give you a table of the density of water by temperature. So look at that. Make sure you know which number. Okay, and you know the density, you know the mass. You can calculate it. You can calculate the volume. That's your calculated volume. That's your theoretical number. Right? And you're gonna plug in both numbers of measure volume and a calculated volume in this equation and find the percent error. I'll say one more time. The calculated volume is a theoretical value. It's a theoretical value. The measured volume right here, that's an experimental value, and find the percent error. Okay. There are 5 containers that you're gonna use. We have 10 milliliter graduate cylinder, 100 milliliter, 50 milliliter beaker, 25 milliliter pipette, and then 50 milliliter burette. This is a graduated, this is a volumetric pipette. The volume right here is highly accurate, but we'll see if it's accurate or not. You have to do it a little bit some like detail that you need to know. So these 2 container, the pipette and the burette, can sit upright on the analytical balance, so you need a container to put water in. Okay, if you don't know what I say, just get to the lab, you'll get an idea. Obviously you can just sit up, like let it sit on the analytical balance, but this 2 you cannot. You need a container. Okay, that's part 2. Now part 3, what do we do? Well, you're going to measure determine the density of an unknown solid. That's an unknown metal. We have a few. Okay, and of course density, we have only one equation, D equal to M over V. Basically, if you want to know the density of this metal, you need to know the mass and the volume. Super simple, right? Now, how do you know the mass? Well, the mass, you can weigh it. Okay, now how do you know the volume of this metal? Here's how we're gonna do. All right, so you're gonna take a graduated cylinder, add some metal into it, look like that. There's a metal down here, right here. And in the burette, you're gonna add water up to whatever it is. Let's say 0. Just keep things simple. Add water up to 0. All right, and then you're gonna drain some water down to this graduate cylinder. Let's say 4 milliliter, about 4 milliliter right here. All right, now take a look right here. If I drain 4 milliliter, the volume that I can read right here is not gonna be 4. You know why though? Well, there's already some metals that occupy some volume. This is gonna be more than 4. Okay, now how do I find the volume of the metal then? Well, it's the total volume. This is the volume of water plus the metal minus just the volume of the water. All right, so if you know initial volume is 0 and then final volume, let's say 4, right? Subtract this number and then subtract from the 5 milliliter, that's a total volume, you'll get volume of the metal. That's it. Okay, the water level doesn't need to be at 0, could be in anywhere, as long as you know the initial volume and the final volume. Subtract that, you get the total volume of water. All right, and then you plug back into D equal to M over V, and then find the density and tell us what density, what metal is that. Each metal have different density, so you know exactly what they are. All right, that's 3 parts in the lab. I know this is the first lab that you're going to do, that we have a pre-lab report and stuff. All right, so let's talk about that real quick. So what do you have to do before the lab? Three things you have to do before. 1, read the lab handout. Okay, you go to Canvas, click on the lab handout right here. So I posted right here. Click on it. You're going to see that it show up like this. All right. I have attached inserted videos. Yeah, how to use triple beam balance, how to use volumetric pipette. You can go read all of those techniques. Okay, so you don't break things or read it incorrectly. All right, go through this lab, and now it tells you what you have to do anyway. I'm just telling you right here, but the same thing. Next one, you will make your pre-lab report. All right, how to write pre-lab report? There are a few things, but I'll give you some example right there. right? So we have Prelab notebook example, flowchart, good flowchart, not so good flowchart, what to do, what not to do. Okay, and lastly, once you're ready, take the pre-lab quiz. We want to make sure that you understand how this experiment works or what you're about to do in the lab. Okay, the pre-lab quiz is due the midnight before the lab start, so make sure you know that. Now, a little bit about pre-lab report. So pre-lab report also include a flowchart. We don't let you bring the lab handout in. So we want you to be prepared. Right? Walk to the lab, you know exactly what to do, not just like read the lab handout and try to do things, follow it. No. You know exactly what to do, step 1, 2, 3, and 4. So we require you to do flowchart. Okay, what is flowchart exactly? Well, it's the picture version of the lab handout. I'll give you some example. All right, if you read it right here, add 2 spatula tips of anhydrous sodium sulfate to dry organic layer. Take a look. You draw exactly like that. So 2 spatula full of sodium sulfate. Okay. Next one, swirl the flask and then allow to stand for about 15 minutes. Swirl, draw it out. Yeah, draw it out, swirl, and then let's stand to 15 minutes. Something like that, right? It has to be detailed enough that you can use the flow chart without looking back to the lab handout. It has to be very, very detailed. Okay. All right. The TA will help you. We'll give you a comment how to write flowchart in a bit later. But let's try first time. Right. Try draw a picture. It doesn't have to be pretty as long as the TA can read it and you understand how to that you can follow use the direction using the flowchart. Okay. Remember though, you are not allowed to bring the lab pen out to the lab. So the flowchart has to be detailed. All right, I think you are prepared now. So if you have any question, send me an email. But before we go, Tyler is not here today, but he sent this to me to send it to you. Just to remind you guys that he's around. Take a look right here. So we have a segment in our podcast called Tyler's Moment. Let's see what he has for you guys. All right, you guys ready? The first time ever playing this. You are my fire, my one desire. Believe when I say I want it that way, but we are two worlds apart that reach to your heart, and I say that I want it that way. Chorus is a little iffy, but that's all right. Tell me why and nothing but a heartache. Tell me why I want it that way. Well, we hope that you enjoy this podcast. And the same thing, if you like us, don't forget to click like, subscribe, rate 5-star, leave a comment if you want to. Right? We would love to hear from you or tell us what you want to know, and we'll just deliver it to you. Right? We are content creator. Okay. We hope that you guys having an amazing day, and hey, enjoy the lab. I'll see you guys in the lab.